lecture. In this lecture, we would be understanding the CLTV modeling. To start with, let's import the packages. We need pandas as PD, Seaborn. Then we need packages from Lifetimes, which is Beta GeoFitter. We need Gamma Fitter. And I'll be explaining what are these different models and how we're leveraging these packages. Then in order to train our model, we need min-max scaler to scale the data. And finally, you need packages like Squarify and warnings. Let's go ahead and understand what is CLTV. CLTV is a measurement of how valuable a customer is to your company, not just on a purchase by purchase basis, but across the whole relationship. Probabilistic lifetime value estimation is made with time projection for a certain time. CLTV is dynamic concept, not a static model. The most basic formula we use is CLTV is expected value of transaction times expected average profit. So let's say you have expected number of transactions for a given customer is 3 and average profit is $10. Your CLTV for that customer is 30. Likewise, it would depend on how much is the recency of that particular customer. If that particular customer comes in a month 5 times, then the average profit will become times average profit will become $50. That's the CLTV for that customer. Now we can basically divide a CLTV into three different value sets. One is high, then medium, finally low. Low might be contributing roughly around 20%. Those are called inactive, non-profitable customers. Then we have active customers, which potentially are 60% contributors towards the profitability. And then the highest, the highest order, which is 20%, which are proactive and very profitable customers. Now, let's get a bit of introduction about beta geometric binomial model, which is BG and BD model. In this model, each customer becomes inactive after each transaction with the probability of P, right? Differences in P follows a beta distribution which shape parameters A and B. We will look at the beta distribution shortly. It should be so that we capture buying pattern of the whole population and then find pattern that will personalize the buying of the whole population. In summary, what will what it will do is learn the mass behavior from these individual behaviors and then make a probabilistic estimation specific to the individual. The following should not be forgotten. After making a purchase, the customer become a partial churn, right? Every time the customer keep making purchase, you make sure that it's likely to be churned over a period of time, right? And that probably will keep growing in general case. The BG and BD model, probabilistic models, to process for the expected number of transactions. Now, let's consider these aspects. One is buy till you die. The BG and BD model probabilistically models two processes for the expected number of transactions. Transaction process buy plus dropout process till you buy. So you are considering both aspects till the point he's active and in making active purchases, and the dropout process, which will know that okay, during the die till the die process there are certain dropouts, so you want to account for those purchases and then account for that dropout as well to make sure you can compute the CLTV based on the active purchases and the dropouts, the churns that's going to happen during the life cycle of the customer. Then the transaction process by is basically we are saying as long as it is alive, the number of transactions to be performed by client in a given time period is Poisson distributed with transaction rate parameter. As long as customer is alive, they will continue to make random purchases around their transaction rate. So every customer would have its own random behavior of purchase, right? And the transaction rate vary according to each customer. They are gamma distributed for the entire audience. And we will also look at the gamma distribution. So the buy process for BG&BD model indicates I'm modeling the purchasing activity of the whole audience with the gamma distribution. Now let's talk about the dropout process till you die. Each customer has a dropout rate. Assuming the probability is P, a customer drops with a certain probability after making a purchase. This is not a full churn. It may return after a certain time. So there was a customer one, made a purchases first 2-3 months, and after that churns out, and then suddenly after a year he comes back and start making purchase. So you have to account for all the scenarios, whether those are retargeting of the customers which were off the platform and the or the customers who have come back over a period of time onto the platform itself. Now the dropout rates vary for each client, and that distribution follows a beta distribution. And the following is a formula basically for calculating the expectancy given the X, and we have bunch of attributions over here. Though the purpose of this exercise is not to go and delve into the details of the formula, but just to give you a perspective of the different acronyms used over here. X refers to the frequency of the customer who have made at least two purchases. TX refers to customer's recency value and must be calculated individually for each customer. Then we have time since the customer first purchase, age of the customer for company tenure, and then we have parameters like R alpha, which basically accounts for the difference in transaction rate between customer parameters of gamma distribution. And A and B basically refers to the beta distribution parameters expressing dropout rate. And finally, we have X, TX, and T are the characteristics of each individual customer. Now, we need to understand a bit more about gamma distribution and beta distribution. Let's come back in the next lecture and understand those distributions. Thanks for joining.